Hey database fans, welcome back for another deep dive. We're tackling a really interesting question today. How much does hardware actually impact database benchmarks?
It's a great question, and one we get a lot. People get really focused on the software,
Right.
but hardware is like the foundation.
Yeah, makes sense.
Let's unpack some of those myths and see what really makes a difference, especially for those of us working with, those massive data sets.
Absolutely. So let's start with the core of the operation.
Okay.
The CPU. More cores, more speed, right?
Well, you would think so, but not always.
Oh, okay.
Yeah, more cores can definitely help, but, if you overdo it,
I see.
especially in those virtualized environments, it can actually work against you.
Huh, interesting.
Yeah, all that overhead from switching between tasks and competing for resources, it can really slow you down.
It's about finding that sweet spot then.
Okay.
What about hyper-threading? Friend or foe?
Hyper-threading, it's a bit of a wild card. It can really give you a boost, but you got to be careful. Older versions had some issues, and even today,
I can imagine.
some databases just don't play nice with it.
Yeah,
Your best bet, test it. Test it with your setup and see what happens.
makes sense. Always test.
Yeah.
Okay, so let's move on to memory. More RAM is always better, right?
What?
More is more.
You'd think so, right?
Yeah,
But there's definitely a point where it just becomes overkill.
really. Too much memory can be a bad thing.
It can. Too much memory can actually make your hypervisor swap excessively, and that hurts performance.
That's so counterintuitive.
It's true. You can even run into something called double paging.
Double paging.
Yeah, it's where both the hypervisor and the guest OS are swapping the same page.
Oh, wow.
Talk about a recipe for slowdowns. And don't forget about database caching. That's super important.
Right, of course.
Some newer technologies actually let you use SSDs to extend your memory,
Interesting.
which can be a game changer for certain workloads.
So it's not just about how much RAM you have, but how you use it.
Exactly. You got to be strategic.
Okay, so let's get into storage. This is a big one. It's the age-old battle. SSDs versus those spinning disks. SSDs are definitely faster, we know that.
Yeah, they're speedy.
But how much of a difference does that actually make for databases?
Storage is huge. It can make or break your performance. And you're right, SSDs are the speed demons.
Okay.
But they used to be held back by those older protocols like AHCI and SASATA.
Right.
But then came along PCIe, NVMe.
Ah, yes. NVMe.
And it just blew the doors off. We're talking incredible data transfer rates.
Yeah, NVMe is a whole other beast.
2,000 to 8,000 millibytes compared to, 600, 1,200 with traditional SSDs?
That's an insane difference.
It's huge.
So are spinning disks dead?
Well, not quite.
Okay.
They still have their place, especially if you need to store tons of data on a budget.
Yeah, that makes sense.
And you can actually squeeze out some pretty good performance from them, too.
Really?
Yeah, with the right RAID configurations. And, get this, by tweaking firmware settings.
Firmware settings.
You heard right?
This is where we go deep down the rabbit hole.
This is where it gets really interesting.
Okay, I'm intrigued.
Things like the read-ahead algorithm and how you size your read versus write cache. Huge impact.
Wow.
Especially with those spinning disks.
So it's like fine-tuning an engine, really getting that optimal performance.
Exactly. It's all about tailoring it to your needs.
Okay, so we've got CPUs, memory, storage, and we're just getting started. What about RAID levels? Choosing the right RAID can make or break your performance, right?
Absolutely. RAID is crucial. And for databases, RAID 10 is usually the winner.
Okay,
Because of its right performance and fault tolerance.
makes sense.
RAID 5 can be a good option if you're on a tighter budget.
Okay,
But yeah, the right performance often lags behind.
got it. So RAID 10 is our champion. You mentioned stripe width and depth earlier. What are those all about?
Oh yeah, those are important. They control how your data is spread across your disks, and they can seriously affect how efficient those concurrent I/O operations are.
Right.
The ones the databases love. It's another level of optimization that people often miss.
Okay, so we've got CPUs, we've got memory, storage, RAID configurations. There is a lot to consider.
There is. And we haven't even touched on specialized database appliances.
Oh, right.
Yeah.
Those are like the heavy hitters of the database world.
Exactly. They're a whole other ballgame.
Things are getting really interesting. But I think we'll have to save that for part 2 of our deep dive.
Sounds good. We'll dive into that world. We'll even talk about the powerhouse, Oracle Exadata.
Ooh, can't wait. Don't go anywhere, listeners. We'll be right back to explore the world of specialized database appliances and how they impact your benchmarks. And don't forget to like, share, and subscribe to stay tuned for more deep dives into the world of databases.
Welcome back. So before the break, we were about to get into this whole world of specialized database appliances.
Yeah, these are the big guns, right? What makes them so special?
These appliances, things like Oracle Exadata, they're really a different breed. They're built for performance from the ground up. We're talking high-end hardware, software that's totally integrated, and they've got some really unique architectural features.
So it's more than just like throwing in the fastest CPUs and the biggest SSDs you can find?
It's way more than that. Take Exadata, for example.
Okay.
It uses tech like SmartScan.
SmartScan.
Yeah, so the data filtering, it actually happens right on the storage servers. You end up moving way less data across the network.
Wow, that sounds like a pretty serious performance boost.
Yeah, it can be significant.
But these things got to be expensive, right?
Oh, they are. And to manage them well, to really get the most out of them, you need some specialized expertise.
Makes sense.
It's not a magic bullet for everyone.
So they're like Formula One cars.
Exactly.
Amazing performance. But you need a whole pit crew to make them work.
Yeah, that's a great analogy.
Yes, if you've got the resources and the know-how.
Right.
These specialized appliances can give you a real edge. All right, so we've talked about CPUs, memory, storage, those RAID configurations, even these specialized appliances. There's a lot to think about.
It's true. Hardware optimization, it's a real puzzle. Lots of moving pieces.
Yeah, dude.
But if you understand how those pieces fit together, you can get some serious performance gains.
And it's not a one-time thing either, right? Hardware is always evolving.
Always. New technologies popping up all the time.
Yeah, so you got to stay on top of it, keep learning and adapting.
That's the key.
So for everyone listening out there, don't underestimate how important your hardware is.
Yeah.
It's not just about the software. From the CPU, the memory, the storage, all the way to how your RAID is configured. It all makes a difference.
It all comes together.
And don't forget those specialized environments like Exadata. For some of you, that might be the key to unlocking those crazy performance levels.
It could be.
This has been fantastic. I've learned a ton.
Me too.
Thanks so much for sharing all your knowledge with us today.
Happy to do it. Always love geeking out about this stuff.
Expert speaker, I gotta say, this deep dive has really opened my eyes.
Oh, yeah.
Hardware, it's not just an afterthought.
Not at all.
It's like the foundation for everything we do with databases.
Absolutely. It's the bedrock. We've seen how these choices, even things that seem simple,
right,
like how many CPU cores you have or what kind of storage you're using, it can really make or break your benchmarks.
It's crazy. And there's always something new coming out, like NVMe SSDs, those specialized appliances.
Yeah, it's hard to keep up.
It can be overwhelming, for sure.
It's a lot, but I think the key is to really understand the fundamentals.
Okay.
You know, those core principles, and then apply them to what you need. It doesn't matter if you're working with a huge data warehouse or a small transactional database. Those principles, they'll guide you to make smart hardware choices.
So for our listeners, what's the big takeaway here? What should they be thinking about when it comes to this whole hardware and database benchmarking thing?
I think the most important thing is to think big picture. Don't get tunnel vision on just one component.
Yeah.
Think about how it all works together. The CPU, memory, storage, even those firmware settings we talked about.
And don't be afraid to experiment a little.
Exactly. Try out different configurations. See what works best for what you're doing.
There's no magic bullet, right?
Nope. What works for one person might not work for another. It's all about figuring out those trade-offs and making those smart choices based on what you need.
This has been an incredible deep dive. Really appreciate you walking us through all this.
My pleasure. Always love talking about this stuff.
And to everyone listening, thanks for joining us on this journey into the world of hardware for database benchmarking. Hope you learned a thing or two. Don't forget to like, share, subscribe to stay tuned for more deep dives into the fascinating world of databases. Until next time, happy benchmarking.